Good afternoon, everyone, and welcome to today's webinar, Driving ROI with AGV Systems, brought to us by FPSA member JBT. Our speaker today is Doug Houghton. Doug is JBT Food Industry AGV Sales Manager. He started with JBT in early 2017 and has since helped several major food companies automate their material handling operations. Doug's material handling automation experience stretches back over 20 years, and he applies this extensive knowledge to every project he encounters. My name is Dolores Alonso, and I'm VP of Membership here at FPSA. This webinar is being recorded, so let your colleagues who are unable to listen to it live today know that they have access to it in the member-only section of the FPSA website. Before I pass this over to Doug, just a few quick housekeeping items. All attendees are muted by default, but you will have the opportunity to submit any questions you have to Dan by typing them into the questions pane on the control panel, and I will read them off at the end of the presentation. So I think we are all set. Thank you so much for taking the time today. I am going to pass this over to Doug, so please give us about 3 seconds to get to his screen. Thank you, everyone. Okay, Doug, I do believe your screen is showing. Thank you.
Great. Good afternoon, all. Thank you so much for this opportunity to just share a little bit about AGVs and how to use them to drive ROI within your current and existing businesses. My name is Doug Houghton, and I am currently located in Oregon today, watching the snowfall, but I appreciate your time. I'd like to just tell you a little bit about JBT and who we are. Give you an understanding about us as a food company, but also as an automation company. So for those of you who may or may not know, JBT was originally founded by John Bean. John Bean invented a continuous pump sprayer in California and sold that into the orchards and so on in California. From there, in the 20s, we became FMC, and which is the Food Machinery Company, and then FMC Corporation, and then FMC Technologies. And then the mid-2000s, FMC's decision to go more towards towards energy and the technology center on that side, they spun off all of the food industry, all of the food components of FMC. With that, JBT was born. And so we went back to our roots as John Bean Technologies and have continued on ever since as John Bean Technologies. So I really reside under the food tech umbrella. The AMHS division, the Automated Material Handling Systems division, is actually under the food tech piece. And we sterilize about 50% of all the world's shelf-stable food. We freeze about 50% of the world's frozen food, and we squeeze about 75% of the world's citrus juice. So I tell people when I talk to them, typically if you ate something today, more than likely it went through a JBT process or a JBT machine. We freeze, we cool, we portion, we bread, all the way through that. Have some great compatriots on the food tech side that are able to help you with any of those needs. We'll be glad to put you in touch with any of them as well. So from there, you jump over into the AMHS, which is the Automated Material Handling Systems Group, which is my group. We've been doing material handling for 125 plus years, and then we've been building AGVs and using automatic guided vehicles. So let me clarify for some. So there'll be terminology thrown around: AGV, LGV, SGV. So lots of different terminology for that. At the end of the day, they really are all the same, and it's a self-guided vehicle or an automatically guided vehicle. So from there, though, so we have over 500 systems installed, over 4,000 vehicles in a variety of industries, all the way through, whether it's food to fast-moving consumer goods, so toilet paper and tissues, bath tissue, paper towels, et cetera, to you name it, we're in that industry as well. We take safety very seriously, and so for over 20 years, we've actually been part of the AGV Safety Standards Committee here in the United States and continue to remain on that standards committee as well. So let's talk. So what is an AGV? Without a show of hands, so I'll ask you all to raise your hand and tell me who knows what one is. And so since I can't see you, we'll just keep going. But what is an AGV? An AGV is an automatic guided vehicle. It's been around since the 50s. When you think back to what they were, a lot of times they would follow a wire in the floor. They would follow magnets embedded in the floor. Or they would follow tape on the floor. And when you think back, 20, 10, 15 years ago, they're battery operated. There's a host system that maintains them and tells them what to do and where to go. And really, at the end of the day, they replace a manual fork truck. And that is the driver for everything, right? Get the labor out of the cost. They're laser or vision guided now in the navigation, and so you put some targets up throughout the facility. The spinning laser on top of the mast will shoot out and give us an accurate dimension of where we are in the building. Using vision navigation as well in trailer loading applications or some other areas. Moving materials all throughout your facilities, whether that's WIP, finished goods, raw materials to the line, to the head of the line, handling palletized and unpalletized loads. Excuse me. What are some of the benefits of AGVs? Simplest one, and the one that we hear the most, is to reduce labor costs. Second thing that is so important and so critical is the safety issue. You don't have vehicles crashing into objects. You don't have vehicles crashing into people, et cetera, et cetera. It's a reduction in the elimination of errors. Too often I hear from my clients, that the current operators take a load at the end of the day, or they'll take a load and they'll bring that load that's directed by their ERP system or their WMS to go deliver that load to a specific location. Maybe there's a load there already, or they don't get all the way to it, and they just put it wherever. Well, that load is now lost, and you'll never find it again. Or the wrong load gets shipped out at the end of the day. So you have a FIFO environment where it's a first expire, first out, and for some reason the wrong pallet is picked and gets shipped. Again, costly errors, costly mistakes. Predictable material flow. So if you have a palletizer that runs at a specific set rate, we can actually program the SGV manager, the host system, to deliver pallets at a specific rate, or a reload or replenishment load of pallets at a very specific rate as well. Inventory management. When I pick a load and I go put that load away without a human intervention, we know exactly where that load is, and we know exactly where it will be when I go back to pick it up. Redundancy, which is very important from a safety aspect. There's no single point of failure for the vehicles. They have safety systems on the vehicles that are restrained or constrained to the vehicle, but then because of the way that the system runs with the host system, there are also things that allow us from a safety perspective to take care of that as well. And finally, the reduction of product damage and facility damage. You'd be amazed at the number of people that are coming to us as well because crashing into the rack, crashing into the conveyor at the end of the line. crashing into each other for that matter, damaging the pallets, dropping the pallets, tipping things over, et cetera, et cetera. So there's a legitimate cost and a very specific cost that you can attribute to those things as well. We're much safer than a fork truck. We recognize that. If you haven't seen this video yet, just hold your breath. It's pretty scary to see that when you start thinking about the issues at hand, and the safety of those employees and everything else. Terrifying to watch that video, to be honest with you. As an old rack guy and as a material handling guy for years, to watch that whole thing just crash and know that it was caused by operator error on the fork truck. So why implement an AGV system? Wanted to kind of run through just a couple of points with you and understand why and what are the business issues that we're targeting and that I hear primarily in my encounters now with folks to be able to see. Finding reliable, qualified labor in an ever-shrinking labor pool. Number one issue when I'm sitting down with people almost from an operations standpoint, from an RLDC or a distribution center standpoint, number one issue is finding that labor. Nobody wants to drive the fork truck. Nobody wants to drive a fork truck third shift for that matter. So it's harder and harder to find those people and to do that. When you do find those people, we find that there's a massive amount of pressure from other industries as well, competing for that same labor pool. Had a conversation with a customer not long ago. Amazon had moved into the area and paid $3 more an hour, I believe, for the fork truck drivers. And folks that had been with this company for 10 and 12 and 15 years left and went to Amazon for the higher rate. So you have this, you lose all that talent and that labor force that you've had for years. Makes it very hard to see, and that leaves a gap. That leaves an intellectual gap in your folks, in your facility as well. Increasing damage costs to equipment, product, and facility. This point goes to the 2 points up above. As the labor pool shrinks, you begin to pick from a smaller and smaller pool. You have some people that maybe are not as good and is not the best and the brightest, choice that you'd get to make. And there are some damage, whether it's to the facility, to the product, et cetera, et cetera. And so you have these costs rising as well because of the top two issues. From a more strategic point of view, how do you gain a competitive edge over the competition? Right, a lot of that, the low-hanging fruit that you've seen for cost reduction, that's been picked. Being bigger, faster, better. Those ways to do things have been solved at this point in time. And so, where do you get further, and how do you gain a competitive edge on your competition? And the way you're going to do that is to improve your costs. And how do you improve your cost? Drive that labor cost down specifically into that. And the third one is improving stock values. Again, increasing profits through a reduction in labor costs. As we'll see here in just a minute, the ability for me to run an AGV system for $3 an hour is very real. So when you look at this, each of you may see yourselves in one of these areas. So if you were to look at the cost of a fork truck over a year, It's about $200,000 a year with the truck, with that human on it, and everything else. That's pretty significant when you begin to see that. So for a case study of why, we can take an AGV fleet and put one group of vehicles in of about 10 people, of about 10 vehicles for less than the cost of a single human on a fork truck. As you can see here, from an operating cost, this is ATL is for automatic trailer loading. And so this was an automatic trailer loading system that we did. The vehicles installed were about $190,000. They operated 24 hours a day, 6 days a week. Into that, it's about $3.30 an hour for each vehicle. So for me to run 10 vehicles, it was about $33 an hour. How could you not want to drive your costs into that? And how could you not want to be able to save that time and that cost in $33 an hour, knowing that right now you have folks sitting on a fork truck that their burden rate is $33 an hour, and that's per each. So great way to be able to solve it for you and to be able to see this is actually a true case study for it in a food and beverage plant in Atlanta in 2009. We installed 11 vehicles, so a counterbalance, which is just like a fork truck. We installed 11 vehicles in that facility, and the vehicles would pick up at the end of the stretch route and deliver them into directly into a trailer, or they would go into the warehouse for subsequent staging and later loaded into the trailer. With the operating lease, it was about a $1.3 million savings to the customer. And then this customer has actually gone on and purchased 5 additional systems from us located throughout the United States. This facility in Atlanta actually just in November added, I believe, another 8 or 9 vehicles to the system. And so it's a great opportunity continuing to move on. And if you recognize that these went in 2009, so this system is still in and running well for over 10 years. So what makes up a system? Obviously, you have vehicles, and they can be forked, they can be unit load, they can be tuggers or towing vehicles or some other sort of special application in the vehicle. And then the system manager, there's a high-level host. There's that sits on a server that's sending signals out and directing the vehicles and directing the movement of the vehicles and the traffic management of the vehicles and so on. And then there's also another set of this, which is a simple unsupervised system, which is just for vehicles that are just going to pick up in one specific location and drop in another specific location where you don't need the host and allow them to do. It's a pretty cost-effective solution for some folks that don't require inventory and big traffic management when you get the systems. As they get into larger and larger number of vehicles, then the system gets more complex, and you have to have that high-level host in order to maintain traffic and so on. So what are some of the different kinds of vehicles out there? It stretches across the spectrum. The large board handling vehicle on the left-hand side of the page, huge vehicle. It's actually pretty cool to see. Takes a stack of board and raises about 273 inches into the air. The stack weighs almost 9,000 pounds. So pretty impressive when you get to see it and you get to see it move. In the middle, just a simple fork-over vehicle. Allows you to work in a little bit smaller of an area. A standard counterbalance vehicle on the right-hand side there at the top. A pantograph vehicle, so being able to do it too deep into the rack and go into single selective rack or into racking and be able to do that. And then on the very bottom on the right-hand side, drive-in racking. So we can actually work in a drive-in racking environment. We're faster and more accurate in the drive-in racking than a human. which is key. Again, it goes to safety and it goes to damage and product damage, but also infrastructure damage. Unit loads. So everything from something really small, the little small lift deck vehicle in the upper left-hand corner, something that you'd see in a hospital. We actually have some hospital systems that have a bunch of vehicles in them as well, all the way up to something that's massive in the blank handling that handles 30 tons. Dual conveyors on the right-hand side, down to batch retorts. So if you're familiar with retort, it's a canning process or sterilization process, and so we have some stainless steel vehicles that handle that as well. Single conveyor, just again handling an unpalletized load. Sometimes you may have it on a slip sheet or something like that. You want to be able to convey it, and we can grab it with that single conveyor. Also do towing or tugging. It's very more accurate, or more appropriate for the automotive industry. We see that more in the automotive industry. I haven't come across it too much in food and bev at this point, just because it doesn't really work itself or lend itself to be as good for tugging. So just because of product, it's more, in my opinion, at this point, more for kitting and some of the other options that go better for automotive. And then some of the specialty handling. Upper left-hand corner again, trailer loading vehicle. Some neat things about the trailer loading vehicle: bigger tires on the back of the vehicle that allow it to cross over the dock plate and then go into the trailer. So when I'm in the trailer, even carrying a 4,000-pound load into the trailer or a 5,000-pound load into the trailer, we're at about 125 psi going into the trailer. So I'm pushing downwards on the downward forcing. The trailer is pretty low. It's actually less than a typical fork truck. It's a little longer and a little bit higher, and so it allows us to cross the dock plate easier. The big blank handling, the forked 15-ton blank handling, the roll handling or a roll clamp, again, taking that in the paper industry and handling the rolls of paper in the industry to be able to do that. Very lower right-hand corner, just a standard clamp truck, and being able to take a clamp truck and grab a load and carry that load with the clamp trucks. Very excited about this, and that is the freezer vehicle. We were approached about a year ago and asked to create a freezer vehicle for a customer, and we are getting ready to do that. FAT will be sometime here in April or May to be able to do that. Taking a 2,500-pound load to 366 inches, it lives full-time in the freezer, and so this vehicle will actually remain in a freezer for as long as it's running, and we're interfacing between a conveyor. So we'll pick up off of a conveyor, take it away and put it into pallet flow racking on the back side, and then we will retrieve it on the front side and drop it back onto that conveyor when it's called to go out to be shipped out. So very excited about that. We're looking forward to being able to see that and see that there's a huge market for that as well. I have a lot of people asking, can you live in the freezer? Can you do that in the freezer? And the 0 degree F, we may be able to go a little bit lower than that as well. It's a sensor issue. So system management, how does it work? How does the whole system run? So we have what is called our SGV manager, SGVM, and it takes and maintains the traffic for the vehicles. It maintains the inventory within the warehouse that we've put in place. We are not a WMS. I'm not a true warehouse management system. I'm more of a warehouse control system. In other words, when I pick it up and I go put it away, I can know where I put it, and I can retrieve it from that based on certain and specific business case rules, whether it's FIFO, LIFO, LIFO, so last expire, first out, or FIFO rather, first expire, first out. And so this SGVM, it maintains all the fleet and tells all the fleet what to do. And so in the normal environment, if I were to scroll over any of the vehicles that you see moving, and I scrolled over the bubble above each one here, so I scrolled over number 5, it would tell me what the current load is on that vehicle. It would tell me if we've captured this data or not, but we could tell you what the SKU is and what the pallet identifier is, et cetera, et cetera. It will tell me battery status and different things like that. Being able to pull that now out and show it on a screen full time, your operators or your folks to be able to see from a supervisory perspective, being able to see that and excuse me, have that opportunity to just be able to interact with the vehicles and see what's happening in real time. We can look at different orders of what's going on with the vehicles. We can also access all the alarm histories if for some reason there's something that's happening frequently in one certain area. Or if you have a vehicle that's giving you some more issues than others, you can go and look at all of that. And then also do some system diagnostics if you're having some challenges with it. You can pull that up and pull up that specific vehicle and look at faults. You can look at any of the issues that have been happening with it. This simple unsupervised system, again, as I said before, this is for simple A to B movements, that there's no inventory tracking required, that there's only 1 or 2 vehicles needed without when you get above that, you begin to have some traffic issues, and so you want to be able to maintain and interact with that. It's standalone, so there's no centralized system that's running them. They do, however, still have their all the safety requirements and all the safety sensors and systems that go to, so it allows you to have that. They do communicate with each other a little bit. When they also communicate with the palletizers or whatever the pick and drop locations are about what that is. The advantage here is that they're lower cost. The vehicle costs about the same, but because you don't have the major infrastructure required from the software and so on, from a host perspective, it gives you that ability to do. So let me jump through here real fast and just so I can show you some things. So what I'd like to do is just walk you through start to finish, allow you to see the vehicles doing their thing from the beginning. So we're bringing in raw material here. We're bringing in bottles. And we're going to be able to go in, automatically unload the trailer, pull this product out, go put it into, if it's going directly to the line, we could deliver it directly to the line. If it needs to be staged and set for a little bit while until it was required, we can do that as well. So we're going to go in. As you see what's happening, we went in as a single fork. We've stretched out and we've become a single double. We'll squeeze the load together here just to give it a little bit of stability and some additional stability as the vehicle backs out. And then we'll back out and go and put it wherever it needed to go. Video doesn't quite do it justice, but for the most part, for the trailer loading, pretty close in the unloading perspective as well. We're about 45 seconds on average from dock plate to dock plate. So gives you a little bit of an idea about timing and so on. Bulk storage, so we can take those cans, bottles, raw materials, whatever it is, and we can go and put them away. Here in this video, if you notice the black and silver target, this obviously requires some stands for targeting so that when I'm out in the warehouse, I'm using my laser triangulation for navigation. And those, because I can't look over the top of these can stacks, we needed some way to identify what that is. So in this scenario, 2 things are happening. We're actually using 2 types of navigation here. So when I'm out in the warehouse, I'm using this laser triangulation. When I go into the lane, I actually take the safety sensor data. I don't turn the safety sensors off. I just take that data because I can use those points for whatever I want. I take that safety sensor data and I use it to do what's called natural feature navigation, or deep lane navigation, as we'd call it in this instance. And what it allows me to do is see the pallets on either side of me, and so I compare what's beside me with what I know on a map on the vehicle, and we can navigate via that. Simple empty pallet stacks, delivering these back out to production. From a raw material perspective, again, this is when you have a fixed time, as we saw with one of the benefits of AGVs, is that I know that I produce X number of pallets per hour, and so we can deliver those pallets so that in this case, the robotic palletizer never runs out. End of line. So we've completed the processes here, and the pallets are now stretch wrapped. I'm going to come out, pick them up here off the end of the line. Two things are happening. So we're actually interacting. The SGV manager, the host, is actually interacting with the vehicle, and the vehicle is interacting with the conveyor at this point, and some of the I/O that's required here. So we've pulled up. We've asked the conveyor, can I pull in? And we go through some safety requirements and protocols there. Vehicle goes in, picks up, and then we'll take it away. From there, I can take it if for some reason, so we'll pick it up at the end of the line, and normally I would drop that straight into a trailer, or I could go deliver that out into the warehouse. But in this case, the trailer that I needed this load to go into is not there. So we're going to take it, we're going to stage it over here. When the trailer arrives, I'll send a vehicle back here, and I'll load the trailer with these. If I have to do it in a specific route or a specific bill of lading or whatever it would be, I can go back and I can pull these pallets, load them directly back into the trailer in that sequence as well. And then finally, we can trailer load. So I can take those pallets right off the end of the line, or I can take them from staging, and then I can bring it and drop it into the trailer. So it's just as a couple of things to note as you look and as you watch and as you understand. From an ROI perspective, from an overall vehicle perspective, from an overall functionality perspective, you can catch a few of the things about the vehicles that we like to really kind of point out. One is just the smoothness of the movement of the vehicle. I'm not driving crazy. I'm not driving over the loading dock and into the dock plate and into the trailers at high rates of speed where I'm going to damage these things. The vehicle's not getting damaged. Your product's not getting thrown around, getting damaged, et cetera, et cetera. It's very consistent. We're not as fast as a human, but I'm more efficient than a human. I don't stop to talk. I don't stop to chat about the sports over the weekend or anything else like that. We just continually move, and we're continually driving the process. That's the end. I'm hoping that I ended it. It just ended just at the right time. To open it up for some questions and see if you guys had any questions for me. I'll be more than happy to answer them for you.
Great. Thanks so much, Doug. Yes, we do have a question. We have two. Does there need to be something special for the load gate going into and out of trailers?
So when we go in and out of the trailer, typically you're going to have certain things at the dock, and you're going to have certain dock requirements there, and so you're going to need a dock lock. You're going to need a human that actually opens the trailer doors, looks inside, make sure that the trailer is clean, and then once they've done that, make sure that there's no broken boards in the trailer. And once they've done that, they'd hit a GUI or a push button at the dock, and allow the vehicle then to enter that. Some of the systems actually will put photo eyes outside the docks and outside the the trailer entrance, so that if a human were to go into the trailer, it would trip and it would prevent the vehicle from going into the trailer until that trip was reset.
Great, thank you, Doug. Also, are there special maintenance requirements?
No, typically if you have a vehicle technicians on staff that are doing some of your fork truck maintenance now, those same guys can really do the fork truck maintenance, the vehicle maintenance on the AGVs. Very similar in what you're asking the vehicle to do. So it's a hydraulic, it's got wheels, there's sensors down the bottom that you're going to need to clean and so on. So from that perspective, the maintenance is really about the same as what it would be for a fork truck. When I say the same, the operation is the same. The timing of and the how often you have to do things and everything else still about the same. But obviously with wheels, some of the other issues that you have with a fork truck, you're not going to have with the AGV. So those maintenance issues go away. If for some reason you had an electronic issue with the vehicle, there is a joystick with the vehicle, so you could back the vehicle up and drive it to a location and get it away from, out of the path of the other ones. And then you'd be able to troubleshoot it from there if need be. I have to say that it's pretty intuitive, so that if a sales guy can walk up to the vehicle and if it's in fault and know what to do to fix it, to get it running again, that's pretty impressive. So, it is pretty intuitive for folks to be able to answer that.
Great, thank you, Doug. And what is the base cost for a freezer AGV?
Oh, I wish I could tell you that. Unfortunately, it's so varied for what that requirement is. And I'm not trying to be evasive on it. It's just that there's so many variables that run into that. How high am I going? What the load is? Am I handling 2 pallets at once? Am I just handling a single pallet at once? Et cetera, et cetera. So there's some things that go to that. That vehicle, the one that we're implementing later on in April, May, I think that vehicle, when it was all said and done to be installed, was around $240,000, $250,000, somewhere in that neck of the woods. But that was with some other vehicles as well. So we have freezer vehicle, trailer loading, and then there's some that are just running around in the ambient part of the warehouse that are doing similar. So hard to really give you an exact number on what that vehicle was.
Very good. Okay, Doug, thank you. And the next question, Doug, is will we be able to get your slides? And you and I discussed that before the webinar. Doug, yes, go ahead, Doug. You can let everyone know.
I was going to say, yeah, absolutely. We can share the slides as you and I have discussed, and everybody can pull and do from there.
Wonderful. Yes, folks, I'll be sending those out once I receive them from Doug. Oh, another question just came through. Doug, can the AGV operate in explosive hazard area?
I would love to have that conversation further, because I need to understand a little bit about the classification for it. Is it true class 1, div 1? What's the real requirement for the explosive proof that you're asking about? But we would love to have that opportunity to chat with you some more. I think there are some things that we could do with the vehicle. Need to run it through some of our engineering and the smart guys in Chalfont to know exactly. But I think we could be able to do it.
Okay, great. And I will send the information for this question to you, Doug, and perhaps you can discuss that offline.
Okay.
Great. Well, that seems to wrap up the questions. Again, thank you everyone for your time today. And Doug, thank you for the presentation. And we very much appreciate it.
Yes, thank you. Thank you all. Have a great afternoon.
You too. Thanks, everyone. Bye-bye.
Thank you.